Hello everyone, I'm Guoquan from Institute of Software, Chinese Academy of Science. Now I'll present our recent work, WebRR, Self-Replay Enhanced Robust Record Replay for Web Application Testing. It's a joint work with Zhenyue from China Southern Power Grid. Web applications are key assets of our society, and the enterprises use the web as a powerful and convenient way to carry out their core business. However, developing large web-based software systems with high quality is a challenge for software companies. End-to-end testing is a technique that tests the application's workflow from beginning to end to ensure the application behaves as expected. The purpose of this kind of testing is to simulate the real user scenario and validate the system under test and its components for integration and data integrity. Here we show an example of end-to-end test scripts for web application. End-to-end web tests consist of a set of test operations. For each test operation, the locator specifies the position of the target element in the page, and the action simulates the user's action. It can be seen that even for this simple scenario, it's not easy to write correct end-to-end test manually for the testers, which usually have no program skills. To facilitate web test development in industry, record and replay techniques are widely used to generate end-to-end web tests automatically. There have been lots of record-replay tools development in the industry and research realms for the web application testing. For example, the Selenium IDE, Catalan, Sakuli. These tools belong to micro-record-replay technique, as they only capture and simulate user inputs while ignoring other non-deterministic events in the browser and the server. Modern web applications are characterized by the dynamic behavior and the ultra-rapid development cycles, and the generated tests based on existing record-replay tools are fragile and can easily break during the playback. For example, the locator in the test script fails to identify the target element. Therefore, it's necessary to design a new record-replay technique to improve the robustness of the generated end-to-end tests. By investigating into 7 enterprise applications from our industry partner, we conclude 4 challenges to design a new record-replay technique for robust web test automation. The first challenge is to generate a visual locator accurately during the recording. Compared to the internal DOM attributes, the visual appearance of an element is usually more stable. Recently, there have been lots of tools which propose to use image recognition technique to identify and control GUI elements. However, none of existing record-replay tools for web testing support to capture the target image in the recording phrase. A screenshot API provided by most browsers are usually asynchronous, and the page may change or jump before the captured image is returned. The second challenge is volatile DOM attributes. Modern web applications are usually run in a dynamic environment. Even for the same page, the corresponding DOM tree will change slightly if it's visited at a different time, as the state of the application may change. DOM locator, depending on such volatile attributes, will fail to locate the target element during the replay, even the version of the application is not updated. Existing tools depend on the tester to filter the volatile DOM attributes, which can incur much inconvenience. It's designed that new designed record replay tool can identify volatile attributes automatically and avoid to use them to generate DOM-based locators. The third challenge is missing low-level mouse motion events in the recording phrase. Most existing record replay tools only record high-level user actions by default, such as click, double-click, while ignoring low-level mouse motion events. However, for the web application used in our industry partner, multi-level hoverable drop-down menu is widely used. If such low-level mouse motion events are ignored, click action will fail to locate the target, leading to the test breakage. Note that Selenium IDE and the URL recorder allows the testers to manually insert mouse over event during the interaction with the application. However, it's not automatic, and the tester may forget it to insert it, leading to the test breakage during the replay. The fourth challenge is the frequent updates of the application. The system deployed in our industry partner are continuously development. It's common to apply regression testing to ensure the main function is not violated by code changes. When the workflow of the application changes, the testing workflow of existing web tests need also be updated. However, local crawling technique used by existing work Vista is not effective when the interaction logic with the application is complex. Without domain knowledge, a crawler cannot expose the workflow that can fix the execution logic of the broken tests. To address the above challenges, we designed WebRR, self-replay enhanced record replay technique for robust web test automation. Similar to existing technique, WebRR also consists of recording and replay phrase to generate and execute web tests. The difference is that in the recording phrase, we design a new self-replay module which can generate multiple different types of locators automatically, including visual locator, DOM locators, and a new kind of proximity locators. It also keeps a critical mouse motion events to improve the robustness of the generated tests. In the replaying phrase, to deal with the test breakage caused by application updates, WebRR applies multiple locators about the target element and the domain knowledge extracted from the new tests to repair two kinds of test breakage, locator breakage and the local workflow breakage. This module will precisely record various user input events when the tester interacts with the application on the test. Similar to existing record replay tools, WebRR captures these events in the application layer by inserting a record library in the rendered page. After capturing events, WebRR further extracts the internal DOM attributes of the target element and its ancestors, which will be used as a clue to build the DOM-based locators by self-replay module. In the recording phrase, WebRR introduced a novel self-replay module to check received events online by opening the same browser in the background of the machine where the record module runs. There are two main advantages by introducing self-replay module in the recording phrase. Firstly, by checking the effect after triggering each event, it can remove useless mouse motion events automatically. Secondly, it can generate multiple locators for the target element to improve the resilience of the generated test scripts to the change of the application, including the visual locator, multiple DOM-based locators, and a new kind of proximity locators. In order to generate DOM locators, WebRR first checks the attributes of the target and the ancestors retrieved from the self-replay module with the corresponding one extracted from the recording module to filter volatile attributes. and then generate different types of DOM-based locators using the algorithm proposed by Selenium IDE, such as ID locator, name locator, and inner text locator. WebRR also supports a new kind of proximity locator, which identifies the target element using its neighbors in the layout. In order to compute a proximity locator for the target element, WebRR first finds the ancestor element of the target, which has the obvious indicator. It then traverses all the leaf nodes in the parent, determine the nodes which can be located using explicit text, and compute the layout relation of these elements with the target. If some kind of proximity locator does not exist, after the above three steps, WebRR will find the layout neighbor based on the coordinates by invoking element from point API. In the self-replay module, the image of the target element can be captured correctly, as the self-replay module can control the replay of the next event after the image is returned. Note that the visual locator may not be unique in the page. Existing work expands the image of the target until it's unique in the current page. However, the whole process is time-consuming. To address this limitation, WebRR leverages other locators to identify the target uniquely. To remove useless mouse motion events, we register mutation observer to monitor the attribute changed nodes in the DOM tree. After replaying a mouse motion event, if there are no mutated nodes in the DOM tree, this event will be removed. If mutated nodes don't include the target of the next event to be replayed, this mouse motion event can also be removed safely. During the replay module needs to address two kinds of common test breakage that are usually caused by the application updates, that is, locator breakage and the workflow breakage. The locator breakage means that the target is still in the current page, but cannot be identified using obsolete locators. Workflow breakage means that the workflow of the application on the test change, and the testing workflow needs to change accordingly. To repair locator breakage, we design a novel voting algorithm based on the generated multi-locator to address locator breakage. Firstly, DOM locators will determine the candidate target elements. In this example, DOM locators will first find two candidate targets, and then visual and proximity locators will vote them. Finally, the candidate element with the highest voting value will be selected as the target, and the locators which find the wrong target will also be updated. To repair local workflow breakage, WebRR first runs the new test developed for the new version of the application to construct the partial state flow graph. Then WebRR runs the obsolete tests. It first uses the multi-locators to try to identify the target in the current page. In the case of the failure, WebRR will query the partial state flow graph to find a path from the current page to the new one, which contains the target element. If this path exists, WebRR will insert the path to the test after getting the confirmation from the tester. Otherwise, it assumes that the target does not exist in the new version of the application and will delete this operation. WebRR is developed to use JavaScript language. The record and self-replay module are implemented as a browser extension which will insert record and replay library into the page. To avoid to interfere with the tester's interaction with the application, the browser in the self-replay module will be opened in headless mode by default. After validating the received events and generating multiple locators for the target, self-replay module will send the generated test operation to the test development platform, where the tester can edit, run, and debug the test script. To evaluate our approach, we mainly investigate the following research questions. Question 1. How effective is WebRR to replay the generated tests on the same version of the application where they are captured? Question 2. Compared to the existing test repair technique, how effective is WebRR to repair the test breakage when the version of the application on the test is updated? Question 3. What's the performance overhead of WebRR to generate multiple locators in the recording phrase and to the repair test breakage in the replaying phrase? We selected 3 web-based enterprise systems from our industrial partner, ESMM, PAM, and EPMS, which are continuously developed by different vendors. These systems are deployed on a cluster environment of our industrial partner for acceptance testing before they are formally released. For the experiment, we selected the 2 latest releases of the application and the accompanied test case. For answer question 1, this table presents the effectiveness results when WebRR was applied to improve the robustness of the generated tests. It can be seen that WebRR can avoid 48 test breakages compared to Selenium IDE. We also investigated the 5 broken tests in WebRR and found that the failure was caused by the inappropriate triggering time of the actions. We plan to address this problem in the future. To answer question 2, this table presents the effectiveness results when WebRR was applied to repair test breakages caused by the version updates of the application. It can be seen that among 122 test breakages, WebRR repairs 106 breakages successfully, whereas Vista Plus only repairs 73 breakages. Specifically, WebRR with multi-locator repairs more 24 locator breakages than Vista Plus. It repairs more 9 workflow breakages than Vista Plus, which only repairs 1. To answer question 3, the locator generation column in this table shows the average time required to generate multiple locators by WebRR and its 2 environments, respectively. It can be seen that for the locator generation, WebRR is 2 times slowed down compared to WebRR DOM, and 19% faster than WebRR Viz. And for the test breakages repair, WebRR was overall 22% faster than Vista Plus. We discussed some lessons learned in the collaboration with our industrial partner. The first lesson is the interference between the record and the self-replay module. For example, when tester delays an item in the record module, this action will also be done quickly in the self-replay module. However, delete this item again in the self-replay module will trigger an alert pop-up dialog, blocking the replaying of the following received events. To address this issue, our tool accumulates the events occurred in one page, and when the page jumps or the events reach a threshold value, they will be sent to the self-replay module. The second lesson is the dynamic iframe. The front end of one selected application consists of some dynamically generated iframes. The actions inside these iframes cannot be captured initially by our tool. To address this issue, we implement a setInterval function to scan the iframes in the page periodically and insert the record library if the iframe is newly generated. For the actions on the non-standard widgets, they can't be captured by our tool currently. We plan to capture low-level events in the operating system layer when interacting with the non-standard widgets, and use the computer vision technique to identify the target. In this paper, we summarize the 4 challenges to robust web test automation based on record-replay technique. We also implemented WebRR, a self-replay enhanced record-replay technique for robust web application testing. The experimental result on 3 enterprise-level web application systems shows that the proposed technique is effective. Thank you.